Today we will tell you the real story about one of the oldest, most special stories ever happened, the Big Bang. One of the oldest mysteries pondered by thinkers across generations is how the universe began. While science has provided a compelling narrative of this story, it remains incomplete. In this video we will share some new research from the biggest universe scientists. What we do know for certain is that the universe, which was once smaller and hotter, is expanding. This expansion began around 13.8 billion years ago, marking the birth of the universe. A significant discovery in understanding the universe's early stages is the cosmic microwave background radiation, CMB, which has been known for over 50 years. The CMB is the earliest light we can observe in the universe's history, serving as an afterglow from when the universe was about 400,000 years old. This moment in time represents just 0.003% of the universe's current age, much like a baby picture compared to a fully grown adult. While the CMB offers a glimpse into the universe's early years, we also know much about the conditions that existed even earlier. At the time of the CMB, the universe had a temperature of around 2,700 degrees Celsius. But prior to that, the universe was much hotter. In modern times, scientists recreate these extreme early conditions in particle accelerators, such as the Large Hadron Collider, which can generate temperatures as high as 7 trillion degrees Celsius by smashing atomic nuclei. Despite these advances, there remain gaps in our knowledge. We have concrete data from as early as a fraction of a second after the universe began expanding, but what occurred between time 0 and 10 to the power of 13 seconds remains uncertain. Moreover, we understand even less about the exact nature of the moment the universe began or what, if anything, came before it. However, informed theories help bridge these gaps. One popular theory is that around 10 to the power of 36 seconds after the universe's birth, it began expanding faster than the speed of light, a phase known as inflation. While this might seem to violate the speed limit set by light, it is actually space itself that expanded faster than light, not objects moving within space, so no laws of physics were broken during this period. The cause of this rapid expansion is thought to be connected to the four fundamental forces of nature: electromagnetism, gravity, and the strong and weak nuclear forces. At extremely high energies, it's believed these forces were once unified into a single force. The moment when these forces separated, particularly when the strong nuclear force diverged, may have triggered the energy needed to fuel the universe's expansion. This event is known as a phase transition, a reasonable and widely accepted explanation for the universe's early development. To explain a complex idea, consider the analogy of a container holding both air and water. When the temperature is above the boiling point, the container has air and water vapor. However, as the temperature drops below 100 degrees Celsius, the water turns into liquid while the air stays as gas. This change demonstrates how two things that initially appear the same can behave differently under varying conditions, similar to how forces in the universe might have behaved differently as it evolved. The concept of inflation and the idea of forces splitting into four are reasonable theories consistent with known data. The timeline of the universe's early moments begins at time 0, and up to 10 to the minus 43 seconds. The extreme temperatures and energy levels cause all known physics to break down. This means that human intuition, based on current physics, doesn't apply to this time period. Between 10 to the minus 43 seconds and 10 to the minus 36 seconds, the universe expanded slowly. At about 10 to the minus 36 seconds, the strong force separated from the other forces, causing a rapid inflation of the universe from smaller than an atom to the size of a grapefruit. This period of inflation was brief, ending by 10 to the minus 32 seconds. After the inflation, the universe continued to expand, but at a more steady pace, or coasting. By 10 to the minus 13 seconds, the universe's expansion still continued, and this is where scientists have solid, observational data. Any period before this time, including the moments immediately after the Big Bang, is speculative. While this speculation is based on sound reasoning, it remains hypothetical. All known physics only apply after 10 to the minus 13 seconds, where our data becomes reliable. At time equals 0, we don't have the means to understand what exactly happened because physics as we know it fails. Without major breakthroughs, it remains impossible to know what conditions were like before 10 to the minus 43 seconds. Science, in this case, admits its limitations. This lack of knowledge is not a flaw, but it would be misleading to claim certainty where there is none. There are ideas about how the universe might have behaved, such as the visible universe being extremely small but still a part of a much larger or even infinite universe. Focusing on the visible universe, it was incredibly tiny, much smaller than it is today. All matter and energy were compressed into a microscopic space, though not a point of zero size, which is a common misconception. The true nature of the universe at that size is unknown because the known laws of physics don't apply to those conditions. One theory suggests it might have resembled modern spacetime, where matter and energy fluctuate. Misunderstandings often arise, especially when discussing concepts like the slowing of time in the presence of strong gravity, which adds to the difficulty of imagining what the universe looked like in those first moments. The passage discusses various theories and ideas about the origin of the universe and the nature of time, emphasizing the uncertainty that surrounds this topic. One key point is that, from the perspective of general relativity, the Big Bang expanded both space and time, but the known laws of physics don't apply before a specific point in time, 10 to the minus 43 seconds after the Big Bang. As a result, claims about time not existing before the Big Bang should be viewed with skepticism, and any ideas about what happened before this moment are speculative. Three main ideas are explored regarding the universe's existence before the Big Bang. The first suggests that the universe always existed in a supercompact state and transitioned to its expanding state through quantum mechanics, similar to how nuclear decay works. This theory assumes the universe existed forever, though what time meant in this state is unclear. Other ideas propose more dynamic scenarios, such as the possibility of additional dimensions or multiple universes interacting with each other. The second idea speculates that our universe might be one of many, existing in higher dimensions that we cannot perceive. It's compared to the way birds move in 3 dimensions while humans are restricted to 2. In this scenario, our universe might have collided with another, releasing the energy that led to its expansion. Although it's difficult to prove, some scientists have suggested testable hypotheses to explore this theory further. A third concept, called eternal inflation, envisions the universe as part of a continuous process where universes bud off from one another, similar to blobs in a lava lamp. In this model, our universe originated from another and may, in turn, give rise to more universes. However, like the other ideas, this theory is difficult to confirm due to the lack of empirical evidence. In conclusion, while scientists have made significant progress in understanding how the universe evolved from a hot and dense state to its current form, there is still much to learn. With no clear answers about what happened before the Big Bang or at time equals 0, the exploration of these ideas continues. Scientists remain open to new discoveries that could shift our understanding of the universe's origins. Thank you for watching. Make sure to follow the channel and give this video a like. See you next time.